All right, so for today's lesson, we're going to be talking about regression, and we've seen regression a little bit in Algebra 1, but we didn't really go that in depth with it. So in Algebra 2, we're going to have three different types of regression that we can use. We have linear, quadratic, and exponential. And I have all of these equations written out at the top of this page for you. So what we're going to do is we're going to be given a set of data, and we're going to have to figure out what's the best type of regression for that data. And we also might be given a set of data and it tells us what kind to use. So even if it's not the best necessarily, if it says to use exponential, you have to use exponential to get the right answer. And we have to make sure we pay attention to rounding directions and make sure we get that wrong. Or get that right. So a lot of the delta math questions will require you to round to a certain number. So make sure you pay attention to that so you don't get them wrong. All right, so looking at this first example, we're going to go ahead and type this into Desmos. So the way we do this is we hit this little plus in the top left corner. So we're going to hit plus and then we're going to hit table. And what we're going to do is just type it in. So if we, and you can kind of see that it's already going to auto-populate because they're the same distance apart. So make sure that when it does that, that your x values match what you have in your table. So we're going to go ahead and type in the y values now. All right, so if you can see, I have a tiny little sliver here of the window, but I can't really see any of the points that we just plotted. So in order to see that, we want to hit this magnifying glass to the left of the table, and that's going to show us kind of what the graph looks like. So what we want to figure out, and this is going to be kind of the challenge with these, since we have exponential or quadratic, we kind of want to figure out what's the best choice here. So I'm going to go ahead and type in our quadratic because we could have that U shape. We don't have the left side, but it could work, or it could just be exponential. And before we do that, before we type anything in, let me refresh you on what these graphs look like. So linear is just a line. Quadratic is going to be a U shape. Remember, that can be upside down also. And exponential is going to look something like that. So you can kind of see why this graph would maybe fit both quadratic and exponential. So let's type them in. So I'm going to go ahead and type in y1. And the way to get the 1 after is just to literally type the 1. You don't have to do anything special. And we're going to hit that tilde. And you can get it on your keyboard. It's also if you hit shift with the key next to the 1 on your keyboard. And then we're going to type in, I'm going to do quadratic first. All right, so there's our quadratic. And you can kind of see it doesn't really fit it very well. It's like it kind of hits some of the points, but not really. And I'll show you how to check which one makes the most sense in just a second. So let's type in our exponential now. All right, so now we see the green line is our exponential, and you can kind of tell that it fits it a little bit better. Still not quite that perfect, but what we're looking for is we're trying to compare these r squareds that we have over here. So if you look where it says statistics and then r squared, we have 0.9946 for exponential, and we have 0.9849. So we're looking for whichever number is closest to the number 1. So 0.99 is going to get us closer, so we're going to use exponential for this one. So I'm going to go ahead and write that our regression type is exponential. And you maybe would have been able to tell that because it kind of like they're all really close together, then suddenly it pops off. Usually that means exponential. All right, so for our equation, this question doesn't give us any type of rounding. Let's go ahead and round this to 2 decimal places. So I'm going to ignore this. I'm just going to erase our quadratic because we picked exponential. And we're going to write this in the form y equals a b to the x. Okay, so we're just going to fill in the a and b that Desmos gives us. So we're going to have y equals 157 point, and I said to the 10th. So we're going to round it, and we're going to have 0.8. And the b value is 1.8 if we round it. And we're going to have to the x. Okay, so that gives us a whole equation that can match this set of data the best possible. So we also need to be able to predict a number of bacteria after a certain amount of hours. So the easiest, quickest way to do this is to just go to your keyboard and type x equals whatever number it's asking us for. So x equals 7. And we're going to look for where that purple line that pops up crosses the green. And if you just click or tap, then it's just going to pop right up. So 7 is our x value. We're looking for the y value. So 9657.35. Because we're talking about bacteria, I'm going to go ahead and round down. I'm going to round to 9657. So there are approximately 9,657 bacteria after 7 hours. I'm just going to put bacteria because we should always have a unit. Okay, and that's about it. So something I want to touch on too is that sometimes you'll be asked to use the rounded equation to solve, which is going to change your answer just a tiny bit. So if we need to find the rounded equation, we're just going to type in the equation we wrote. So 157.8 times 1.8, and it gives us our x value is 7. So we're going to type to the 7th power. So see, it kind of changes our answer a decent amount. Now it says 9660 would be our answer. And I didn't round up because we can't round up to get more bacteria in like a real world situation. So I'm just going to round down, or I'm just going to truncate it, which means just take off the decimals. Okay, so you can tell that they're kind of different answers. They're like off by 3. So that's why it's kind of important to read the directions and follow along with what it says. Specifically in Delta Math, it's going to be more testy with you than I would be. All right, so let's do another example. So now we have our table is sideways. So we have our x values in the first row and our y values in this. So we're going to go ahead and type this table in now. But notice that our table is sideways. So what we have to remember is that our x's are in the first row and our y's are in the second. So make sure you don't just, some people struggle with that a little bit. So type that in. And this one auto-populated for me. Just make sure, like I said, to check to make sure that you hit every number that you're supposed to. All right, so let's see what that looks like. So I'm going to hit my magnifying glass, and you can kind of tell that we have a situation where the dots are kind of going up and then they come back down. So that's going to mean that we have a quadratic function. And we can say it's not the other two because we don't ever have a part of an exponential graph that's going to be increasing and then decreasing. It's going to be either one or the other, and same thing for linear. So we're going to go ahead and type this quadratic equation in. So we're going to have y1 tilde okay. And what we're going to do is write that down. So you can see that it has for r squared 0.99, so it's a good fit. So if you were questioning that, you know now that it's good. Regression equation. So it says y equals ax squared plus bx plus c. That's what we're going to fill in our a, b, and c for. So we're going to have y equals negative 18x squared plus 58.5x plus 18, I'm going to round it to one decimal place, 18.4. All right, if we want to predict the volume with side length 3.5, then we're going to just type in x equals 3.5, and it doesn't say anything about using the rounded equation, so I'm just going to go ahead and use what we have in Desmos. So x equals 3.5. Look for that red line, see where it crosses our graph, and that's going to cross at 2.625. And let's make sure we use the correct units. So it says volume, side length, that's a typo, but it's inches cubed. So we're going to put inches cubed. All right, so for number 4, now we're going to predict with the side length 5 inches. So if we type 5, now we're going to scroll down again to see where it intersects. And we're going to get negative 139.125 inches cubed. And here's where our regression kind of fails on us a little bit, because we can't have a volume that's negative. Like, we can't have a negative figure. So we can only really predict so far into the future, in quotes, of this type of question. So this kind of just doesn't make sense in the real world, but this is what works for our equation. So we're just going to say doesn't make sense. Okay. All right, let's do 2 more together, and then I'm going to have you do the last 2 on your own. So we're going to go ahead and clear all this out, and we're going to type in the next table. Okay, hit the magnifying glass so we can see what we're working with. And with this one, you can tell pretty clearly that that's going to be a linear function. So I'm going to go ahead and write linear. And remember, on your previous page, you have what your linear equation is. So we're going to type that in. Okay, so you can tell that it fits pretty well. Our r squared is 0.99, which is what we're looking for. So we can go ahead and fill out what our equation is. So for our regression equation, when it's a line, we're going to have y equals ax plus b. So we're going to have y equals, I'm going to round to 2 decimal places this time. So we have 1.13x plus 21.58. Okay? And I'm just picking for these, you'll be told in a question if it's important when to round or where to round to. So let's do, again, we're going to do the rounded equation, and we're going to do just in Desmos. And we're going to see if there's a huge difference. But just remember that based on the question, that's what's important. So predict the length after 10 months. So we're going to type in x equals 10. We're going to go, and we have 32.952. And I think it's in inches. So we're going to put inches. So let's see if we type in our rounded equation, how that affects our answer. So 1.13, parentheses, it says x is 10 plus 21.58. So we're just plugging x is 10 into that equation. So rounded, we get 32.88. So it's really not that far off. But again, if Desmos if Delta Math asks you to use the rounded equation, use it, because you'll get marked wrong, and I know y'all don't want to do extra work when you technically got the right answer. Okay, so for the last one, let's see what we have. So let's type in our table, hit plus, and I want to show you on this one, if we type in our x values, it's going to auto-populate and put a 2 there, but we don't go to 2, we go to 3. So I'm going to type 3, and then we have to type in our x's because there's no consistent pattern. And that's going to happen a lot with regression. So type the rest of our table in. Hit our magnifying glass. And now we can see we kind of have like half of a quadratic looking thing again, or it's an exponential. So we need to figure out what's the best situation for this data. So I'm going to type those equations both in and see which one gives us the best answer, the best r squared value. All right, so if we look, we have 0.9999 for our exponential and 0.9936 for our quadratic. So they're both pretty good. And again, this could be a question where they tell you to use quadratic, even though exponential is better, but we're trying to find the best fit in this one. So we're going to go ahead and stick with our exponential because that 0.999 is way closer to 1. So our regression type is going to be exponential. And our equation, remember, it's going to be y equals ab to the x power. So we just fill in our a and b. We'll go ahead and round this to 2 decimal places. So y equals 1002.06. All right, so it's asking us now for the 8th trial. So we want to figure out how many coins remain in the 8th trial. So again, we can kind of compare our rounded versus exact equation. So for this one, x equals 8 is what we're going to type in. And zoom in and see where the blue and the purple intersect. So that would be at 17.816, and that would be coins. So think about that again. Would we round up or would we round down? So if you look at the way our graph is going, since our graph is coming down, we would want to round up for this and we would have 18 coins left. Okay, so we're going to say approximately 18 coins. So let's see if we use our rounded equation, if it changes much. So type in the equation we wrote on our paper. And our x value is 8. So that one gives us 16.83. So we would say 17 coins. So we're off by a coin when we round, but again, if the question asks you for that, that's what you want to do. All right, so go ahead and do the next two on your own, and I want you to show me that you filled out the notes that we did together and those last two questions, and it should be an easy 100 in the grade book for you today. Let me know if you have any questions, and when you work on your Desmos, if you are struggling with decimal places and rounding and all that, let me know and I can help you.